Okay. Hello, everyone. Hope
Hello,
we are
everybody.
audible. Yeah, so it's my pleasure introducing Anshuman Singh sir to you today. So I have been very much honored to be mentored by him and today hosting him for this webinar. So if you don't know him, he has been twice ICPC World Finalist and was part of the engineering team that built Facebook Messenger and one of the initial people who moved to Facebook London. I think that most of you already know him and want to hear from him more than from me. So I will be handing over to him and yeah.
Hi, guys. Thank you so much for the introduction, Naman. Today, I want to cover one thing, which is on how to be successful as a software developer. There's so many resources around that talk about how do you get really effective at data structures, algorithms, problem solving. Um, but the truth is, like, while that is great, what I learned in my life was that when you move to software engineering, you utilize a lot of that learning, but it's a very different battle that you're fighting. So I wanted to share some of the insights from what I had learned then. Hello, everybody. Nice to see you all here. So I wanted to share some of the insights there and just take it as a feedback on some of the things that you should be doing. The way I usually do things is I prepare a checklist every single day. When I'm ending my work, I just check whether I have done well on all of those checklists. So this is more of creating a checklist for all of you guys. And welcome any kind of feedback, anything that you guys might have seen in your career as well. The way I'm going to structure this is actually let me see if I can share my screen. Give me one moment. All right. Are you guys able to see my screen? Great. All right. Cool. So I am going to just share. I mean, there's just the structure for this. The structure is I'm going to first talk about what changes from hard skills, technical skills. I was writing code on a single machine. So, for example, somebody told me, "Hey, I just write a code to find the first 100 prime numbers." I was able to write a code for that on a single machine. How does the same problem, or like what else to do with the same problem when you're writing the code in a software engineering job? So the first part is going to focus on that. The second part is more of soft skills. Basically, how do you hack your growth in a company? Right? Like you'll be working with a bunch of different colleagues. What do you do so that you stand ahead of rest of your colleagues? You grow faster at a company. Again, I was fortunate enough to grow significantly fast within Facebook. Multiple promotions fairly quickly, and these were the things that I had followed. So might work for you, might not work for you, but I would love to share these things with you guys. All right, so starting with the first part, which is the problems when you're solving it on a single machine, um, and when you're solving it in a distributed environment, they have different solutions. So the first change that you have to do is on how you change the mindset to solve problems when you have the same data on 100 different machines, right? So for example, I'll just take an example here, which is, let's say I told you, hey, there is a list of integers that is given to you and you have to sort it. Now, when you're doing it on a single machine, let's say if you're doing it using your problem solving, it is super easy, right? Like most of you guys would just write a sort function and things are done. In fact, most languages have inbuilt sort. You do a list dot sort or sort vector dot begin comma vector dot end, and in one single line your entire array is sorted, which is great. However, think about the case when you have the same list. Let's assume this is a list of a user ID, and every user ID has some score, right? And I have such a popular platform that I have uh, trillions of users. And I mean user not meaning because we don't have population of a trillion people, but let's say assume it's an entity, right? So some entity, and every entity has some score. and I have trillions of these entities, right? And that's why like a single machine doesn't is not able to fit that data on a single machine. So that's why I had to spread it across various 100 machines, right? And now I say, hey, sort this entire list of entities with respect to score. So that means entities with the highest score should come first, and entities with the lowest score should come last. And since it's across machines, so let's say machine one has the highest scoring entities, machine two like the entities after that, and machine three the entities after that, and so forth. Now, if you see this problem, I mean, as long as it was sorting within a machine, you can still use a sort function, which you would um, obviously do. But the problem then becomes once every single machine has data sorted within them, there is no guarantee that there is an ordering between two machines, right? So then you do some variant of merge sorting where you pick pairs of machine and then you merge their data. So you pick machine one and machine two. You do a merge between these two because they both have sorted list between them, and then you do a merging with them. Then you might pick machine three and machine four. They will again do merge sort, and then they will be sorted within them. And then that way you build it up. It's a if you search online, you will find this algo, and this again like is not supposed to be a algo teaching class, so I'm not going to go into depth of it. I would love to, but yes, I mean it uses merge sort mechanism to sort it on a distributed environment. But as you can see, like the problem became a very different problem when it was given in a distributed environment. Very similar thing. Like let's take another example. If I say find the median in a stream of integers. Now, as long as that stream of integer fits on a single machine, um, it's a very standard interview question. You can have a balanced binary tree of the numbers that are coming in, or you can have two different heaps, and then you can derive your median from there. However, when you the data doesn't fit in a single machine and it's now split across 100 different machines, then I would leave you guys to do this exercise. It actually becomes a binary search problem. You start binary searching for your median, and those two are again like very different problems and very different solutions. So the first change in mindset is that the code that you were writing on a single machine had a very inherent assumption that everything is going to be on one machine. All of my data is going to fit in my main memory. That might not remain true when you move to a distributed setting. So that's difference number one. Difference number two. Um, all of you here, I mean, I can read the chat. So uh, assume that you are working in a company which has this multi-threaded environment, right? So let's say somebody here is working at Amazon. Now Amazon has these Java servers, and it's multi-threaded. There's a code snippet there which is very very simple. If x is 5, then let's make y as x into 2. What do you think is going to be the output of the following code? Just type in your answer there, and I will be able to see. Most of you would think that the output of the following code, as in like the value of y after this piece of code executes, is going to be 10, which is true in most cases. However, in a multi-threaded environment, if you have multiple threads doing execution, it is very possible on line number 1 when you checked x was 5, the value of y, the value I was asking for value of y. Um, on line number 1 when you checked x is equal to 5, and for that thread the value of x was 5 and you went in, but before you could execute the second statement, which was y is equal to x into 2, there is some other thread that changed the value of x. So for a single threaded, yes, y's value will be 10, which is 5 into 2. But when you have multiple threads, then the value is not guaranteed to be 10. It is possible some other thread just between these two lines, change the value of x. So that is another thing, like the code that you read, they might not behave as you would have assumed them to behave in a normal competitive programming scenario, or a or when writing code on your simple machine, which was always single threaded. So again, like the resolution there is, you can either put a lock there. I'm sure, like, if some of you might have studied operating systems, and there were mutex locks there, so you can either put that so that you ensure that there is only one thread executing this piece of code at a time. So you can put a lock on x so that nobody else can change the value of x. Or somebody just suggested that make x as constant, so nobody can change the value of x. Well, actually, you can make x as constant only if that is allowed as part of the application, right? Like if your application, in your application, x was supposed to, let's say, denote the number of online users, then it cannot be constant by definition. It has to change as the number of online users change. So yeah, Mohit suggested, like, we make this segment synchronized, which is very similar to just taking a lock, which that will actually also work. But I'm just telling you, like, the transition that happens, right? Like when you were writing code on your single machine, you didn't have to care about that, right? Like if I said you've written this code, and you were debugging this code, and like you look at this, you're guaranteed that y's value will always be 10 at the end of execution of this block. That's not guaranteed in a multi-threaded production environment. So you have to be cautious of those facts as well. Let's look at the next thing. Uh, the other thing that you will realize, and this is again from my personal experience, when I was in college, I used to pride myself on writing code that was obfuscated. I would write code that is obfuscated, hard for other people to understand. I would maybe use certain operations which would be more optimized. For example, for taking the maximum greater than question mark equal to, this performs better, slightly better in C++ for taking out the maximum rather than the max function. Um, but just writing the same code um, in a production environment is not good enough, because in your company, this code is not just for you. It is for you and hundreds of your team members who are also going to maintain this code. So every single code that you write, you have to assume that you might not remain at the company a year from now. There should be other people who should be able to come and read the code and clearly figure out what is happening in the code. That means your variables need to have very descriptive numbers. And in fact, this is what Amazon also tests for in their interviews, because they want this to be sort of built into you. So they optimize for code readability, because they know that, like, if you have empathy, if you want the other teams to also succeed, you will make your code very readable. So your variable names need to be proper, which denote what they are supposed to do. Your code needs to be readable, in the sense that if you look here in the second part, with the equal to operator, there is space before, there is space after. With less than operator, there is space before, space after, so that the other person can very easily understand what is the variable being compared and against what. Uh, Even the function name instead of f, which could be anything, now seems to be more descriptive. Instead of writing m greater than question mark equal to, now we are using the max operator. So you have to, as you move from a competitive programming environment into a production environment, you also have to write code that is actually readable, that people can understand quickly. That also means you have to document your code. I'll actually come to that right after this. There's another thing here, which is code duplication. Now, this is something which doesn't come very naturally to us, but I'll actually tell you what happens in actual scenarios. Let's say I had written these two functions. The first function is just checking whether a user has passed a course or not. And let's say hypothetically, a user passes the course if their score is more than 1,000, right? So what I did was I wrote some code to calculate their score, and then I checked if the total score is more than 1,000, let's return true, otherwise return false. At the same time, let's say there was another piece of code somewhere that wanted to calculate user score. So I wrote another function which was find user score, which that did exactly this. So the exact same code has been replicated here, and I'm returning the total score here. Now, hypothetically, let's say I figured out that there was a bug in this code. Now I have to fix that bug at two different places. Imagine if I would have replicated this code 100 times at 100 different places. Um, I would have had to go and change code at those 100 different places. Um, that means if let's say I want to just change this to say that total score now is not absolute, but it's relative. That means I would rank every user. The highest user gets 100, the second highest gets 99 or whatever, and then like so forth. For changing that, I will have to change the logic at each of these places, which is very cumbersome. That means that as you move to production environments, companies try to optimize for reducing uh, duplication of code. So they would rather want that any code that has been duplicated, you create a function for it, and then every single reference point is calling that function. So then when you have to fix that code, you only change that function. So there's only one place where you're changing the code rather than two or three different places. This again is not very important in a competitive programming, because as long as the code works, as long as it gives the right output, everybody is okay with what you wrote. But as you get into a job, this becomes important, and this is something you should keep in mind. Let's look at the next thing, which is what I was saying in just the slide previous to us, is like the code should be readable. At the same time, you should document your code. Now, this is the mistake that most top programmers make. They believe that documenting the code is a waste of time. Why should I be documenting my code? This is completely non-productive. It's not getting a new feature out. The truth is that you're writing code not just for now, unlike competitive programming or participating in contests or participating in a hacker rank test. You're writing code for the next 5-10 years. If let's say you go and work at Amazon, if you go and work at Microsoft, if you've written really beautiful code and your whatever you worked on is still functional, it will probably be there even 10 years from now, 20 years from now. And that is what you should try. I mean, your whatever code you write is your baby. It's your production, right? You would want that to be with people. Even 10 years from now, people should be able to say, for example, that this code was written by Archit or Bhupendra or Arshad or Aditi, right? So, and you should feel proud about that. So for that reason, it's very important that you document your code well. So even 10 years from now, if somebody comes and reads your code, and they will be able to understand the code fairly well, they look at the structure of your code and they say, person who wrote this code was really had cared about me, because they took this additional effort to help me understand what this code is doing. And that's when nobody changes your code. To succeed in a software engineering job, there are two things that happens, which is unlike what you do in college. Code reviews. There, whatever code you write, nothing goes into production till somebody has reviewed your code. Somebody will review your code and leave you advices on what mistake you made. Make sure that every single code review that you get is a learning opportunity for you. Ask yourself the question, did this code review teach me? And you should be willing to give it back as well, right? So become a master at code debugging. In fact, even today, if you're in college, look at code samples from different people, help them debug your code, because this will help you when you go and join a job. Code debugging is important. When you do code reviews, if you're not able to pick out on bugs by reading through the code, it is possible that a buggy code goes into production and it breaks your system. Let's say if you were building Messenger, it would be, and you were the owner for it, you would be really sad if somebody wrote a code and you were not able to figure out the bug there and it went into production and Messenger was down. So you would want to become a master at code debugging. Um, all right, so let's go to the next part, which is now the other thing is a lot of us judge each other by just the knowledge of data structures and algorithms. I remember, I mean, when we were in fourth year, um, people would compare each other on who knew how much on data structure and algorithm, or how much research somebody was doing. I mean, those were the two parameters on how we would compare each other. The truth is that while data structures is really good for to help you be effective at your job, it is not enough. It is not enough at all. Um, and one of the couple of examples I gave, right? Like one was a multi-threading environment, one was this distributed environment. Then there are other aspects, like for example, there is high level design, and I'll give you an example for that. So let's say somebody told you that build a system which can shorten my URL, which is what you call as tiny URL, right? Like I have this big link. Can somebody shorten it and give it to me so that I can share it at different places? And when people click on that link, then they get redirected to the right big URL. Now the service is very simple, right? Like anytime somebody requests you to just shorten a URL, you generate some random code. You make that tinyurl.com / that code, and you return that tiny URL. And when somebody tries to access it, you just, since you've stored that, now you also have to store the tiny code to actual URL mapping. Since you've stored that, you can look it up and then you can return the right thing. Now, think about the case when your system has grown so big that all of the mappings that you have, which is your tiny URL to the actual URL, all those mappings cannot be stored on a single machine, right? So my machine, let's say the laptop that I have, it's a 1 terabyte laptop. I have generated so many entries that now my laptop is full and I cannot store the entries here. So in that case, let's say now I have two machines that are storing this data now. Some of the data is on machine 1 and then some of the data is on machine 2. So when somebody asks me, hey, what is the URL corresponding to the tiny URL, let's say XYZ, then I search whether XYZ exists on machine 1 or machine 2. If it exists at either of those places, I look up the corresponding entry and I return it back. Very simple. However, let's say somebody comes and says, please shorten a URL for me. Now, when I shorten the URL, let's say the code that I generate was ABC. Now, before I store it, I want to be sure that ABC has already not been generated before. So I go and check in DB number 1, which is machine number 1, and I go and check in machine number 2. Let's say I did not find ABC. And now I proceed to write ABC in machine number 1. It is very possible at the same time there was another thread on machine number 2 that was doing the exact same thing with ABC. So it also checked machine 1 and machine 2, and it found that there was no ABC in machine 1 or machine 2. And as a corner case, both machines have now an entry for ABC. That becomes a problem, because when somebody comes and now asks you for what is the corresponding URL for tinyurl.com / ABC, now you have two conflicting entries. There's one entry on machine 1 and now there is another entry on machine 2. That means there is a consistency problem. So these kind of problems arise when you are working across different kinds of systems. Again, I know I would have loved to go into depth of this case study, but again, this is not really a study on high level design, so I can't go into depth. But all of this comes as part of system design or high level design, right? Like you're trying to design systems, design components, so that your system is foolproof against any kind of consistency issues or availability issues. You do it when you're designing large scale systems. Very similarly, there is a area of study which is called low level design. This is that once you have figured out your components from high level design, how do you structure your code so that it is, when you have to add a new feature or when you have to add a new object or a new actor, for example, let's say take Amazon, right? Amazon might have a tons of feature today. When they have to add a new feature, how should you design your code so that the additional amount of work to add a new feature is as less as possible? I'll give you an example, and this is again a very rudimentary example, nothing to do with the real world. But assume, let's say somebody said, "Hey, actually write a code where you design this creature called lion, and lion can eat, drink, walk, and sleep." So you write a code and you sort of define how eat works, how drink works, how walk works, how sleep works. Now tomorrow somebody else comes and says, "Now I also want to support a dog who can do exact same things: eat, drink, walk, sleep." In your format, you'll have to duplicate the same code for a dog and then redefine those functions. But it is possible dog and lion might have some similarities. Maybe they eat the same thing. The eat function looks exactly the same. So in the current case, you're duplicating code. But if you use OOPS principle, which is object oriented programming principles, you can probably define a parent class which was animal, and then lion could have been defined there, and a basic eat, drink, walk, and sleep function is defined for animals. So as you add more animals, you probably don't even need to implement certain functions. Those just get carried forward, right? So your additional effort of adding a new feature or a new actor becomes significantly less. This is a different area of study altogether, which is called low level design and design patterns. There are a bunch of books on that. We'll actually post links to certain books that you can read on your time on design patterns. Some of the design patterns are builder pattern, which exists in Java. Factory pattern, builder also exists in Python. There are singleton patterns, and so many more features, design patterns, and different design patterns are valid for different use cases. The third thing is, which is also, by the way, checked in interviews as well, is how do you interpret questions? Can you gather requirements? For example, let's take the same example of tiny URL, right? So I say, "Hey Archit, why don't you define, like, build a tiny URL," right? And Archit says, "Great, very easy. I'll build this service that stores the tiny URL to actual URL mapping in a database, and I will return whenever somebody says, ki, give me the mapping of tinyurl.com/xyz. I look up the mapping and I return the actual URL." Great, all done. Now tomorrow, the person who had actually asked you came and says, "Hey, I actually want to see statistics. I want to see who is accessing which URL, what location are they accessing it from, what browser are they accessing it from, which age group is going to what kind of URLs." And you say, "Shit, I haven't built that. I'm not tracking when people are requesting, who is requesting. I'm only tracking tiny URL to actual URL mapping." So you forgot to store it. You lost all of that data. And when you lost your data, then there is no way to recover it, because you can't replay what happened in the last 7 days. So, but if you knew this requirement before, if you knew that statistics was important, you would have designed with that in mind. So when somebody gives you a problem, and in real world, in your job, usually problems are going to be not as well defined as you get in a competitive programming, right? Like competitive programming has everything defined. It gives you limits. It tells you what cases are possible, what cases are not possible. But real world problems are not that well defined. When you're defining Uber like cab service, you don't know, like at what speed cars might move. Maybe the driver goes to sleep. Maybe people are not reachable. There's so many different corner cases that nobody told Uber in the beginning. They had this big scandal that happened in Delhi that was never specified as part of the problem. You have to go and gather all of those requirements. You have to foresee a lot of these corner cases yourself. That is what would make you more effective as a software developer, right? Never jump to solutions. The first part is gather requirements, understand what the end user might want. The other thing is, a lot of us think, and this is just a myth, that CS fundamentals are not important. As long as I have done well with data structures and algorithms, I'm going to do well in my job. The truth can't be further away. Um, all of what you learn in as CS fundamentals in operating systems, networking, databases, everything gets applied. If you do not understand databases well, then you'll not be able to create the right indices. You'll not be able to create the right schema. You'll not be able to make the right choices. If you do not understand operating systems, then I mean these are very common problems. If your code base is in C++, there's so many times that your application would have some kind of memory leak. Memory leak is basically when you're allocating an object. I mean, for example, you can say that a is equal to new int whatever, but you forgot to free a. I mean, so free the memory that you allocated for a. So it is very possible you have memory leaks and then you do not understand how to debug those memory leaks. There are these softwares that help you analyze the memory and what kind of objects there are, but those softwares don't tell you like this object is of type this, it was declared on this particular line. That is not what they will give you. You'll have to understand how memory is managed, how paging is done, to be able to make sense of that information. Java, for example, has garbage collection, right? So Java doesn't care about memory leaks. Java says, "Hey, actually, I'll maintain references to objects that you create. Whenever an object does not have any more points of code referencing it, I'll automatically my garbage collection will kick in and it will free it." Now, garbage collection would has different kinds of variables, different kinds of lives of variables. So how do you tweak your garbage collection for your application? Because there are different kinds of application, right? There are certain applications um, where you want your requests, uh, you have a lot of parallel requests, and in parallel they are very low on memory footprint, and they get executed quickly. At the same time, you have these requests that might be very heavy, right? For example, I want to fetch my news feed in Facebook. Now, fetching a newsfeed for me, if I want, let's say, 100 different items in one go, that is very heavy on memory, right? Because I am getting like 100 different posts, along with number of likes, the content, and a bunch of links that might be in those posts. So, so I mean, even understanding that for my kind of application, how do I need to tweak garbage collection? That also is requires you to understand memory management well. That requires you to understand how is memory managed inside, let's say, a Unix operating system. So again, like CS fundamentals are important. Just busting a myth here. This is, I heard somebody say it, so I wanted to make sure you guys understand that if you have to be successful as a software developer, CS fundamentals are important too. All right, this is the biggest myth that I have seen with people around me. When people move into their new jobs, they believe that writing unit tests is beneath them. It is somebody else's job. Somebody else should come and do it. It doesn't help me build a new feature. I should just be writing code, building a new feature. Why should I go and write test? The problem is, you write tests so that no other person, and you have to assume that there will be people who will not have the same kind of understanding as you do. There will be people who will not test your part of the code. They change something else for their own use, and your part of the code got affected. You want to write tests to make sure your part of the code is not affected. For example, the earlier case that we took, that there was a function that calculated some user's score, right? And let's say, for my part of the code, I wanted that the scoring function gets changed a little bit, so I make some tweaks there. But that function could have been called from 99 other places as well. There is no way to guarantee that those 99 other places are not affected and something doesn't break. um, so you write tests if you were one of the persons using it from one of those places, you write unit tests so that when this guy changes this function, your unit test immediately starts failing, and somebody comes and tells this guy, hey dude, what did you do with the code? This unit test is failing, you should go and fix it. So the writing the test helps you with the initial parameter which I told you, which was make sure your code is written to survive for the next 10 years. Even in 10 years, there are people looking at your code and admiring what you did. um, if you write tests, that is going to happen. If you do not write tests, then somebody or the other is going to come and break your code, and then somebody or the other is going to come and change your code. So your code will not survive 10 years. All right, so we're done with the hard skills part. I'll take questions, by the way. Right after I'm done with this, I'm going to finish. I'm going to finish this part quickly, and then I'm going to take questions from all of you guys. Just please take notes about what we are discussing today, and then I'll take questions. Now, software aspects. This is more of how do you hack growth within a company. Um, the the most common mistake I see people doing is that they believe that their manager is somehow always judging them, and that is why they don't open up to their manager, and they crib कि माय मैनेजर, यार मेरा मैनेजर ऐसा है, प्रमोशन नहीं दे रहा है, यार मेरा प्रमोशन हो नहीं पा रहा है, आई डोंट नो व्हाट इज गोइंग रॉन्ग. Just translating it in English, I mean, they crib that the manager is at fault for not promoting me. My manager hasn't been helping, or like I'm not being promoted, I'm extremely unhappy about that, right? You need to make sure you're talking to your manager very clearly. In fact, the conversation that I used to have with my manager was, look, I want to get promoted as soon as possible. Tell me, what do you expect me to do to be promoted? And the answer there was, in Facebook, there were levels defined. And the answer there was, as long as you're doing what is the duty of the level above me, if I am already doing that, then I can be promoted. So the manager would very clearly outline for me, look, here is what you should be doing if you want to be promoted. Again, I'll give you my personal example. So the first promotion, I joined, and I had asked very similar question on the second day of my joining my team. And my manager told me, look, here is, I've seen you in the first 2 days, you've been writing code for this particular component. If you start owning this component end to end in the next 6 months, I'll get you promoted. So then I knew what I had to do. My manager was my friend, and he was helping me and sort of helping me draw a path to how do I get promoted. You guys should do something very similar, because your manager's job description is to help you grow. The job of an engineering manager is to help their reportees grow, to help them perform better. The manager is there to help you. They're not there to always judge you and stop your movement upwards. So that's the first thing. Second thing is, the second mistake I see people doing is they demand ownership. They say, I want to work on this component. Please ask the other guy to not work on it. I'll do it, and I'll own it, right? For example, let's say there is a service within InterviewBit, which let's say takes care of engagement. Maybe let me take a different example. Let's say there's a part of the InterviewBit that takes care of how mentors function, how the sessions are done, right? Now, if somebody comes and says that I want to do it, and please remove the other people who are working on the mentor piece of code today, I want to take ownership, then that usually is not really executable, because if I go and remove the other person who are working on it, what explanation do you give them? The solution there is that if you really are interested in working on something or in owning a component, you start contributing there. You start looking at what is broken there, you start fixing it. Over a period of time, you would have made so many changes to the component, which are again like on the positive side, that people would automatically start seeing you as the owner of the component. They know that nobody knows that component better than you do. and then you automatically become the owner. You don't need to ask anybody. So don't demand ownership, earn ownership. That was lesson number 2 on the softer skill side. And when you do this, like, you start be doing better than your peers automatically. You don't really have to go and demand things from people and or start a fight because you were unhappy on something. Now, the third mistake that I see people do, and that is on both sides, getting feedback as well as giving feedback. I'll actually address the giving feedback part first. uh, Most of us, when we graduate out of university, we are very raw, right? Like, you talk to your friends in a very informal fashion. um, you even abuse your friend and your friends are okay with that. If something is wrong, you're very okay being very harsh to them, and your friends, being friends, they understand. However, that doesn't work in an office like scenario. Look, I mean, you might go and join a company, there might be 10 other people that you don't know of who might have joined along with you, and there might be people who are senior to you as well, right? Now, when you see something which is broken, or when you see somebody who has made a mistake, and if you really feel very strongly about what you're building, if somebody made a mistake and, let's say, created a bug in your code, you would feel really bad about it, and you'll go and give a very harsh feedback. You don't know anything, तुम्हें कुछ नहीं आता है, क्या कर दिया तुमने मेरे कोड के अंदर. um, and but the thing is, when you give a feedback like that, that feedback is not constructive. You're not helping the other person understand how not to repeat the same mistake again. And especially when you attack the other person, they then start holding vendetta against you. They rather, instead of improving, they start thinking ki, how did this person talk in that tone to me? I will show him, I will do something which will hurt him. You don't want that to happen, right? Like, your the reason why you went and gave feedback to somebody was not to create enemies. So there is a very simple framework of giving feedbacks. This was actually created by McKinsey. Um, so the simple framework is, when you are giving feedback, do not express emotions or opinion. The first part of the feedback should only be facts. For example, I'm going to take an example scenario so that it makes sense. Let's say InterviewBit actually hires problem setters to create some problems for contests, um, or let's say like assignments within Scalar Academy. Now, let's say I have hired a problem setter, and I had asked the person to create a problem for a contest, and it was a very, very important contest. So the person created a problem, did whatever they could from their end, but in the contest, let's say the problem broke. It had wrong test cases. So we fixed it, but like, obviously, like, that was not a very good thing to happen, where like you have this very important contest happening and there was this problem which was broken. Now, there are two ways of handling it, right? Like, I go to the person and I start saying that, hey, you are so incapable, you couldn't even handle setting a problem for this contest. I had told you this was a very, very important contest. Why couldn't you have tested it properly, and all of that? The person actually gets angry. The person becomes uh, starts holding negative feelings about me in their heart. However, if I go and just tell them fact, if I tell them, hey, person X, you had set a problem called ABC for this contest. That is a fact. The person cannot deny it. ABC had a problem in the test cases, and we found that out during the contest. It was not fixed before the contest. What I feel is, we should be more diligent going forward. And the way to do that is, maybe we should be testing them by writing solutions in different languages and checking whether those pass or not. Now, when you give the feedback in that tone, the other person knows that you're not expressing your opinion or emotion, but you're rather telling them facts, and they cannot hold a grudge against you for stating facts. So your feedback should always be driven by facts, and then maybe corrective actions, and be willing to discuss corrective action with the person. When you're getting feedback in a very similar way, you should always be asking for feedback. I mean, even when you know you're doing well, you should go and ask your manager, your peers, hey, how am I doing? Do you think there's something else that I should be doing differently? and there would be people who would not have seen this presentation and will give a very harsh feedback, sometimes to you. And in those cases, make sure you don't take feedback on your ego. You you understand the underlying reason that somebody is giving me feedback is because I did something wrong. How do I fix what went wrong? How do I figure out corrective action for what went wrong? If somebody is giving me feedback, one very common thing that we do is we get defensive. We start saying, "अरे नहीं, but ये ऐसे नहीं, actually तो ये ऐसा हो रहा था, इस वजह से ऐसा हो गया. It wasn't my fault. I actually had good intentions, but look, the situation was like this, which is why it happened." Don't get defensive. Let the other person complete, and try to reason. Maybe there was a mistake on your end. Whatever little, accept that, and say that, hey, I'll figure out a way of fixing that going forward. When you do that, then you improve over a period of time. If you get defensive, if you never accept that you make a mistake, look, all of us make mistakes. If you do not accept, you will never improve. So always get feedback, never take it personally, and figure out corrective action. While giving feedback, be very polite, state facts, and state corrective actions that you feel. When you do that, you will move up the ladder because people will like you. You don't want to create enemies anywhere, especially so in your current company, right? The last thing, I promise this is the last thing. As I said, be nice, be respectful, do not create enemies. Mostly you would have to work in teams, more so because teams can get done a lot more than you can individually do. The third thing which a lot of people do is they spend too much time on counting how many lines of code I have written or how many number of hours I've spent in the office. Don't do that. Look at impact. What should I do so that, let's say, my product becomes better, more people start using it, and state that. I mean, when somebody asks you what have you done in the last 6 months, there are two kinds of people. There is a person one who would say, I have written 1,000 lines of code in the last 6 months, and I have gone and done these many meetings, and I have done some X and Y and Z. And there's a second person who would talk about the change that brought. That person would say, hey, actually, in the last 6 months, I have increased the number of users using the product from, let's say, 100,000 to 200,000. I have reduced, let's say, latency or the time that the service used to respond back with by let's say 100 milliseconds. So when you state impact, that's a very positive sign for the person who is asking you for what you've done, right? Like managers usually optimize for impact rather than what number of lines of code you wrote or like how many number of hours you spent in office. And the last thing is, and this is again like something which was very common within Facebook, there was a very term which would go around, which was growth mindset. Always think about growing, no matter where you are. You might be the CEO of a company, you might have already become like this VP of your organization. Even then, always keep thinking about what do I need to do next so that I grow. Have a growth mindset. And usually growth happens when you learn new things. So prioritize learning new things. Never be afraid to take risks. Maybe today I am coding in Java. This new company that looks very exciting codes in Ruby. It's okay. I'll learn Ruby and then I'll be able to go and do well there. So do not be afraid of learning. Always prioritize learning. If you are capable, then everybody would want you. The best job guarantee is capability. Nothing else can give you job guarantee. Jobs go away. People get laid off. But a capable person is always in demand. So always focus on growth, learning, building capability. If you're capable, you'll always be in demand, and you'll as a result, you'll end up making a lot of impact as well as a lot of money. I mean, both happen in parallel. So that is all from my side, guys. These were my learnings, personal learnings. Again, there are some of you who might have had different learnings, but I would love to take up questions as well, and
Yeah.
Naman is also
Uh,
here.
sure. Thanks, Anshuman. So, guys, I will be taking questions from Slido, and you can post your questions here in this link, or the link is present in the description of this video. So we will be taking questions from there, or you can put your questions in the comments. I will be taking from both the sides. Okay. But let me send the Slido link again in the chat in case you are not able to see. Sure. Okay. So let us start with the questions. The most popular question we have is that for CP we mainly focus on algos and TS, right? But what topics should one be proficient for building large scale systems? I think in the chat you mentioned about high level design and low level design. But is there anything specific in them? How to learn them? And also, I mean, like an extension to this question is a question from a person who is not from a CS background. So, as you mentioned, that CS fundamentals are important, and the high level and scalability things are important. So, how can he learn those things?
Right. So usually, like, there are people who learn in two different sets, and like, there's some people who find it easy to learn on their own, like being very motivated all throughout. um, for them, I mean, if you want to learn, let's say, high level design, there are a bunch of resources on the internet. There are some very good books. We'll post links and resources just after this session is over, where we would give you links to some of these resources. In general, like, there's a blog called highscalability.com, which discusses the architecture of different websites, how um, how have different companies scaled. So will post resources there. You can go through it. And there is a second set of people uh, who might not have the same background as other people, and they might not be able to understand these resources at the in the same fashion as somebody else might. um, there are a bunch of courses that are there all around. I mean, there are some paid resources. For example, educative.io has some good content on high level design. um, Scalar Academy at the same time does very formal a course with proper teaching material on both HLD and LLD. So you can join Scalar Academy. That also will help you. Um, at the same time, like, when it comes to CS fundamentals, now people who come from CS background, who have spent time in colleges, they have gone through formal coursework of doing that. Even if you're not, that doesn't put you at a disadvantage. There are still ways of learning it. And to be honest, like, you don't need to go and read the entire book for operating systems. There are certain things that get used more often than not. Some people are saying that Modi has asked to light candles. Uh, Guys, you can light candles at the same time. Don't worry, I'm not going to stop you from lighting candles. Um, anyway, so when it comes to learning CS fundamentals as well, again, like, Scalar Academy addresses that piece as well. But if you're again interested in learning on your own, we'll post some resources for CS fundamentals, HLD, LLD. These are free resources on the internet. You can go and read up there. uh, it might, if you're able to understand and go through all of it on your own, it would suffice. If you struggle consuming the content, then you should look at certain courses, paid courses that are there, which have live learning and which have mentors who can answer your doubts, which will help you understand these guys.
Sure. So the next question is, during the session you had discussed that how building systems is different from competitive programming. But if we have to talk about some skills from competitive programming that helped you at Facebook, were there any skills from competitive programming that helped you there, and what were they?
When you do competitive programming for a while, there are two or three things that you learn to do. One is, if you look at development cycle, let's say Sachin is a developer, right? And if Sachin is spending 10 hours developing something, the typical pattern is people write code for 2 or 3 hours, and then they debug the code for the next remaining 5-6 hours. Majority of the time is is spent on debugging. So if you've done competitive programming, if you keep writing code very often, the chances are, I mean, you do well in competitive programming if you make less bugs. Like you're able to get your code right in one go. I mean, your code compiles, runs just in one single go. So one thing which you get really good at is writing bug-free code. So your efficiency as a programmer goes up, because you've written these complex codes and which have run in the first go, right? So one is writing flawless bug-free code, saving you time on debugging. Um, Two is that when you're working with a very large system which has a large code base, uh, the one skill that you really need is that you go through the code once and you're able to understand what is happening in the code. And then, like, again, the more coding and the reading through other people's code you have done, the more skill you develop. So that also helps. That being said, most of the principles that you learn in DS Algo, for example, like we would solve a lot of problem on network flow, max flow. All of these were not utilized in the dev work, um, but like the process to get there, the process to understand all of these principles, they help because it got me to a position where I could write bug-free code. I could understand code quickly because I had just seen so much obfuscated code in the past.
Sure. So there is a question that how to deal with repetitive or the work which we don't like in project. I think you were fortunate enough to work on projects that were making an impact and probably you liked it, but many people are not at that situation. So how can they deal with that and learn alongside it?
Right. So yeah, that is again another another problem with a lot of work. I mean, and that happens with all kinds of organization. Even if you are studying at, let's say, or you're working at, let's say, Amazon, it is possible like there are certain teams that have very repetitive work, which might not give you enough opportunities to learn. I would say even in those cases, if your work is repetitive, the good thing is like your work isn't very challenging. You can finish your work quickly, and then focus the rest of your time to figure out what are the um, things you can do to upskill yourself, right? So as I said, like learning, I mean, when we talk about, for example, high level design, not everybody gets to design components, not everybody gets to architect these high traffic systems. If there are 100,000 developers, then probably 100 out of them get that opportunity. That being said, if you understand that, that makes your transition into an SD2 or SD3 or an architect faster than everybody else.
Okay. So there have been some people are asking what are some good books how to develop that growth mindset. Do you have any book recommendations for that?
Actually, there are a bunch of books. Somebody actually in the chat had posted the 80/20 thing. I actually, on the growth mindset, I have never read a book, but it's been more through my own personal experiences talking to people. That being said, uh, there are books like 0 to 1. 0 to 1 is actually a very um, strange choice because it talks more about startups. But if you just read through the book, you'll understand um, like how the psyche is around growth most of the time, how compounding works. Even if I'm growing by 2% 3% every day, that compounds to become a huge number over a period of time. um, the so I mean, I'll actually research and then maybe suggest books. Right now, in my personal experience, I did not have to read a book. I just experienced that through people around me.
Okay, so there is a question that when to say that it is done with a company, when to quit a company. Is there any particular situation that happens that you just decide that nothing more is possible here? So when to quit?
Right. So if you're in a job and you're thinking of quitting, there are a few things that you should consider, right? So usually why people should stick around for more time in a company is because if you keep switching very often, you don't get to learn enough, because usually when you go and join a new company, it takes you about a month or two to get used to how things happen in that company. And for you to actually build something which has enough impact, it takes you about a year. Um, but let's say you entered a company, you saw that, hey, actually, um, the culture is really bad. Uh, Usually, if you're in a situation where there is a lot of politics, and people who butter up their managers get promoted, other people do not get promoted in spite of the contribution that they're making, um, then it's probably not the right place for you. You should look at moving out. If you're going and talking to your manager about these things and how to progress forward, and the manager is dissing you, they're not willing to cooperate. Good organizations do not have those attributes. They look at investing in every single employee. They want to optimize for every single employee's growth. If you are at a place where people are willing to invest in your growth, then you should stay there, because even though today you might be in a project where you're not getting to learn a lot, it is possible when you talk to your manager and you express your concern, the manager might be able to draw a path for you where you move to a project where you might get to learn a lot.
Okay, so there's a doubt from a person who probably is shifting from a startup to a MNC. He says that in a startup, focus is on speed of coding and not much on code quality. And now, suppose he is trying to shift to an MNC, will it be a problem? Because in MNCs, there is a lot more focus on code quality. So, is that a hindrance or is that a problem?
Yes, initially there will be. Initially, probably for the first 1 month or so, you'll see that there is so much more attention that is given to code quality, and you'll feel
Frustrated by it, because you wrote a code, you know it works. Now somebody is telling you to go and change that code. You did some changes to code. Some people came up with other suggestions. Then you change that as well, and there's just so many much back and forth happening on the code reviews, um, which causes frustration. But believe me, it's just going to be there for about a month or two at max. Post that, you'll get into the habit of writing code that is structured, and that is actually good for you. I mean, like, understanding how to write code that is of very high quality, that is good for you. What is going to happen though is, like, depending on what team you end up at your MNC, the amount of impact that you were able to make at a startup versus the MNC, that might go down. But again, um, it's uh, it's dependent. It's dependent on, like, which company you are at, which team you are at.
So there's a question on any advice to freshers on what to focus on early in the career, and an addition from my side, what not to focus as well early in the career.
Got it. By the way, today's session was primarily on things that you should focus on, what you should focus on and what not to focus on. For example, um, bad thing to focus on is हिंदी में एक वर्ड होता है शोषा, which is just like how flashy a company is, but doesn't really focus on getting people the right amount of learning. For a fresher, I mean, I would always say you should optimize on learning. Maybe you join a company and you figure out that the company is not helping me learn a lot. So then you talk to people around you, figure out a path on how do you get to the learning path. Um, but the first 2 or 3 years of a career, the first 2 or 3 years when you join a job, they are formative years. That's when you are experiencing software development in a real life production environment for the first time, and that's when you start forming opinions. That's when you start, I mean, imagine you're a baby, and then, like, you're learning how to walk, how to run, how to stand. You want that the people who are teaching you those things are the best people, and the company where you're getting to learn all of this is best, and you're learning the right things, right? Like, you're optimizing for learning. A lot of times what happens is, you go into a safe company, but in the first 3 years you don't end up learning enough, and then you see that there is a batchmate of yours who also has 3 years of experience, but that guy actually knows a lot more than I do. And then that's not a great state to be in.
Sure. So the next question is, what were the most challenging situations or tasks that you faced and were able to resolve in your professional life at Facebook or interview bit?
Hmm. At interview bit, it was actually just dealing with people, um, internally as well as externally. I mean, all of what I'm able to tell you today is my learning from the past, and I wish somebody had told me all of this before. All of this I had to try and do and fail and then learn, right? For example, the entire thing about the framework of giving feedbacks, I've been at the other side where I've given feedback to people harshly, just because, I mean, when things don't happen, you get angry, right? And then you shout at somebody, or you give them a feedback in a very, very rude tone. And then you realize after introspecting that that maybe was not the right way of giving feedback. How do you handle, I mean, machines are easy to handle, humans are not. Humans have emotions, humans have aspirations. So managing people, that was one thing which was extremely challenging for me. uh, Two was, in general, even the growth mindset that people talk about. I remember there was a phase of 6 months even within Facebook when I couldn't focus on the right things. I would be focused on short term things. For example, um, let's say I am leading the uh, reliability and latency team for Messenger. So there were occasions when I was focusing on slightly short-term benefits, and I would just over-optimize for that. I would spend a lot more time that was required, versus not focusing on something which maybe required a month to do, but would have much bigger impact. Maybe it would have reduced the error rate to 1/10 of what it was. So prioritizing the right thing is something, again, which it took me time to learn. Uh, Slowly I developed that. I remember an incident actually from my college days, from the competitive days, and I was reading through some of the messages, so I was able to see what changes have come. Uh, so in my competitive programming days, there was this coder called Triple M, who was a very, very helpful coder. That person would actually help out everybody who would approach them. I remember when I was just getting started. I just, like some of the other coders, had reached out to him for help and figuring out why my code was not working. And Triple M was again very busy man, so he did not reply. After a while, I again followed up. The person replied saying that he doesn't have time, and I wrote a very, very harsh and rude message to the person. It's now that I realize that maybe I mean, there is a better way of handling people. There's a better way of giving feedback. There's a better way of managing expectations. I mean, the person was doing me a favor. Why should I be rude or harsh to the person? So these are things that you learn with time. My major learnings is handling people and prioritizing the right things, long term things rather than short term things.
So a question is, what is the benefit of staying in a company for long period, even when you are not getting much hikes? Are there any benefits to stay? And what are the disadvantages of switching companies often?
If you switch companies often, then you usually, like, let's say if somebody comes and interviews at interview bit, I ask them what is the impact that they have made in the previous organizations. The If you switch too often, you'll never have a good answer to that question, because you haven't stayed at a company long enough to change a lot of things. You cannot say that, hey, actually I worked at let's say growers for a while, and I was able to increase their order volume by 20%, or I was able to increase the number of people visiting the site by 10% by the changes that I did, or I made the site faster by 20%. Right? You'll never be able to say that, because you've never spent enough time understanding what is happening within. And growers is just an example, guys. Please do not quote me there. I just took a random example. So you never spend enough time within growers to understand how things are working there, and change things for the better. But if you spend enough time, then you're able to create these impacts, and then you're able to talk about them when you go outside, right? It is okay if you're not getting hike initially, but if you know a lot more than somebody else who might be at a higher salary, then salaries would auto adjust themselves. As I said, like, capability is the best job guarantee. um, your current position is not. There are CEOs that keep getting fired here and there. There are CTOs that keep getting fired here and there. If they know the right things, if they are actually the best capable people out there, then they get rehired. Otherwise they go out of job. You don't want to be the person who goes out of job.
So question is, how often should you ask feedback from your managers? Is there, I mean, like whenever you want or anything like that?
So I usually had the framework of I had set a one-on-one with my manager to happen, a formal one-on-one every 2 weeks. So every 2 weeks, I had reserved this 30-minute slot on my manager's calendar where I would make sure that I talk to my manager for 30 minutes. And the theme of that was talk to me about things that I'm doing well, talk to me about things where I need improvement. And again, like re-stressing on the fact, look, I want to move to the next level. What should I be doing? What am I doing wrong? What am I doing right? Tell me what else should I be doing. So the whole reason why you want to do this is because you never want last minute surprises. You might believe that I am performing really well. You do not want that at the end of the year or in 6 months, whatever is the frequency of review, your manager comes and says, hey, actually you were a bad performer. You don't want that happening. You want your reviews to be as surpriseless as possible. Whatever the review, you knew it was coming because you've been talking about that for the last uh, every 2 weeks anyhow.
Okay, so let us take the last question for the day before we end. So, do you suggest a depth first methodology to learn, basically go into depth of each topic, system design, a programming language, even data structures and algorithms, or a breadth first approach is better? I mean, like have a high level overview of multiple topics, but being master of none. What do you?
Actually, there are both kinds of engineers, and both end up doing well. There are people who specialize in something, in the sense that there are some people who become, let's say, a data engineer, or a systems engineer, or if well, even within front end engineering, like specific on a certain tech stack. And at the same time, there are engineers who you would call as generalists. Both are in demand, both are good positions to be in. But do whatever you're doing, either depth first search or breadth first search, really well. I mean, it's, don't go half-hearted at any of those. um, Even within breadth first search, there's one caveat: make sure you know enough. Do not there's a phrase in general when explaining things which is called hand waving. Hand waving means that you know of certain terms, certain fancy terms, and whenever somebody asks you a question, you use those fancy terms to explain without really understanding what is happening beneath. So if you know less, that is okay, but whatever you know, you should have very solid knowledge on it. So never always question what is happening, and never have superficial knowledge where you're just hand waving. Even within breadth first, you need to manage that too. So both approaches are fine, as long as you're not doing hand waving in any of those approaches.
Sure. Thanks a lot for taking out your time today. I know it's a weekend and still you took a time. Thanks a lot. So thank you guys for listening to us. We will be posting the books and the other resources in the comments soon. And yeah, have a good night and enjoy. Happy weekend. Bye bye. Good night.
Sure, we will post the resources very very soon. Thank you so much. Thank you so
Sure.
much, guys, for being patient with me and bearing with me through this session.
Sure. Definitely. Advices that you gave today will definitely help me in my career as well, and hopefully to the listeners who all saw this video. Thanks again.
For those